Hey everybody, Mr. Schachter here with an exciting video. Related rates is the subject this time. Objective of this video is to examine related rates and create a plan to solve them. So this will just be the introduction video. We're going to do some examples in the next video. But the goal here is to examine related rates. Now it's important to move forward with the knowledge that every rate in this chapter, or this section rather, is going to be a rate with respect to time. So it's going to be d something with respect to time. So this dt is going to be very important. Every single function in this problem will have a respective time when taking the derivative. Okay? What that basically means is something is changing over time. So time is like the measure. Okay? Let's go ahead and get started with a couple of just examples of what relating rates means. So relating rates means to take two rates and create one equation from mathematics that contains both of those rates. So we'll start off with an easy one. Number one says the area of a circle is changing and the radius of a circle is changing. So these are two rates of change. And the formula in mathematics that contains both the area of a circle and the radius of a circle is very simply the area of a circle formula. The area of a circle is pi r squared. So I know that the area of a circle, which is right here, and the radius of a circle, which is right there, both of those are contained in my one equation. Okay, so I related those rates using one equation. Number two is also sort of easy. It says the volume of a sphere is changing and the radius of a sphere is changing. Well, that's just the volume of a sphere formula. Volume equals 4/3 pi r cubed. And that has the volume of a sphere and the radius of a sphere. So that is the single equation that relates the two rates provided. Number three is a little less obvious, but not too bad. It says the measure of an angle is changing and the side of a triangle is changing. So in a triangle, any triangle, you're looking at an angle changing and a side changing. And what you're really dealing with is some type of trig function. Trig function. For example, let's suppose you have, you got a right triangle, and this angle we'll call theta, and this side we'll call s. And you're also going to be given another side, like the length of another side. Maybe it's like 10 or something over here. And then you'd have to understand that the one function that relates these two rates, the rate being the angle and the side, is a trig function. Specifically in this example, you have the opposite side and you have the adjacent side. So the trig function that would be relating these two rates in the picture drawn is the tangent function. Tangent of theta is equal to opposite s over adjacent 10. And in this formula now is your formula that relates the two rates. So it's a single formula that contains the variables theta and s that you need. Last, maybe two sides of a right triangle are changing. So in this picture you've got a right triangle and maybe you've got side A and side B, and they're both changing. And the rate that you would use in this example is the Pythagorean theorem. A squared plus b squared is equal to c squared. No matter what two sides you were given in a right triangle, those are always the ones, that's the formula that could relate any of the two sides. So the Pythagorean theorem would be your formula there. Now this equation that you're creating that relates the rates is always the function that you differentiate. So whether it's the area, the volume, this trig function, or Pythagorean theorem, those are the functions that you take the derivative of. Your respect, as mentioned in the previous slide, with every variable is time. Okay? Let's make a plan. Here are a couple of beginner steps to get started. Number one, understand the problem. In particular, identify the variable whose rate of change you want to find or seek, and the variable whose rate of change you know. I always start my rate of change problems, my related rate problems, with understanding, number one, we know d blank dt, and number two, we need d blank dt. And these rates are both found by simply reading the problem, okay? Every time I do a related rate problem, I always start by writing this down. This helps me focus, it helps me understand the problem, and it helps me pick the equation that's going to relate the two rates. So I'll start every problem with that. We know and we need. Number 2, develop a mathematical model, draw a picture, try to understand what constants are in the problem and what things are changing over time. Number 3, then you're going to create your equation, usually a geometric equation that relates the two rates. Number 4, differentiate both sides implicitly with respect to time. Number 5, substitute any values that depended on time. Be careful, this step is a little tricky. Be careful not to plug things in too soon. If you plug something in the problem too soon, and let's say, for example, you were measuring the rate of change of a rope, and you wanted to figure out how much it was changing when there are exactly, let's say, 3 feet out. And you plug the 3 into problem too early, and then your dt for rope or whatever would basically just differentiate to 0. So you can't plug information in too soon, and we'll kind of go over that as we're solving problems. Number 6, interpret the solution. Try to figure out what the units are and how that makes sense. So let's go to the next video where we're going to actually do some problems.